Structure of atom. Structure of atom. We know atoms and molecules. We know there are different states of matter: solid state, liquid state and gaseous state. All states of matter made up of extremely smallest particle called atom. Different atoms join to form molecule. Same or different atoms join to form molecule. We know atoms and molecule. We learned previous chapters. Atoms and molecule. The term atom first suggested by John Dalton. Scientist John Dalton introduced the term atom. Okay, according to John Dalton, atoms are the smallest part of any matter and atoms are indivisible particles. According to John Dalton, atoms cannot divide again. This is the smallest part. But later onwards, further experiments shows that atoms consist of subatomic particles. Atoms again contain smallest part such as electron, proton and neutron. Electron, proton, neutron, these together we will call subatomic particles. Subatomic particles. Okay. Subatomic particles are electron, proton, neutron. Electron represented by E, proton P, neutron N. And this together we will say subatomic particles. Okay. And see here, here I am giving you some activities. Okay. Here two activities are here. Here, you know, plastic comb or plastic pen. Rub on here, then you just show it on small paper piece. Then see here what happened here. Also you can see here another activity. You have balloon. This balloon rub with some cotton. Okay, then you just show your hand near to this balloon or you bring two balloons together. So you observe what happened here. Okay. Okay, so this experiment shows that when you rub materials together, they receive charge. When you rub materials together, they lose electron or they receive electron. After that, they become charged. They will get charged and they will attract together. This type of charge called electrostatic charge. Okay, when you rub plastic pen on your hair, then it will attract small paper piece because this pen receive charge. Okay, electron will receive or electron will lose. Okay, after that this pen become charged and it will attract small paper piece. Same thing happen on balloon also. This type of charge is called electrostatic charge. Electrostatic charge. Clear? Next one, we have to understand here more details about subatomic particles. Subatomic particles. We know electrons, protons, neutrons are subatomic particles. I told you before, the term atom first suggested by John Dalton. According to John Dalton, atoms are indivisible particles atoms cannot divide again. But further experiment shows that atoms consist of electron, proton and neutron. This electron, proton and neutrons are called subatomic particles. See here, electrons are represented by E, proton P plus. Here electrons we can represent like this, E minus. Okay, electrons E, electrons have negative charge, protons P, protons have positive charge, neutrons are chargeless particles. So these are subatomic particles and we can represent these subatomic particles like this. Okay, also we have to understand here, electrons are discovered by or electrons found J.J. Thomson. J.J. Thomson discovered electron. Okay, and electrons have negative charge. Protons are discovered by Rutherford. Proton discovered by Rutherford and neutron discovered by Chadwick. Okay, electrons J.J. Thomson, proton Rutherford and neutrons Chadwick. Clear? So these are subatomic particles, electron, proton, neutron. Also we have to understand here, electrons negative charge, protons positive charge. Okay, the magnitude of charge same, but they have opposite charge. For example, look here, electrons have minus 1, protons plus 1. The charge of electron minus 1, charge of proton plus 1. So it's mean the magnitude of charge same, both are 1, magnitude 1, but they are opposite charge, plus and minus. Clear? So electrons and protons have equal magnitude, their charge equal magnitude, but they are opposite charge. Okay. Here we have to understand atoms are electrically neutral. Atoms are electrically neutral. Atoms, the net charge of atom is neutral, no charge. We discuss atoms consist of electron, proton, neutron. Electrons have negative charge, protons have positive charge, neutron no charge. Atoms consist of charged particles like negatively charged electron, positively charged proton, but the total charge, the net charge of atom is 0. Atoms are chargeless particles. The total charge of atom is 0. What is the reason for this? Atoms consist of equal number of electrons and protons. Number of electrons and protons inside the atom will be same number. Electrons have negative charge, protons have positive charge. So this negative charge and positive charge will be cancel each other. That's why the total charge of atom will be 0. Clear? Okay, next one. We have to understand here structure of atom. Structure of atom. The first structure of atom introduced by Thomson, J.J. Thomson. According to J.J. Thomson, see here, according to J.J. Thomson, structure of atom like this. Okay, he considered atoms like a positively charged sphere. He considered atoms like positively charged sphere and negatively charged electrons are embedded on it. Negatively charged electrons are uniformly distributed in positively charged sphere. Okay, so according to J.J. Thomson's, atoms like a positively charged sphere and negatively charged electrons are uniformly distributed on it. Okay, also here Thomson's model of atom also called plum pudding model of atom. Plum pudding model of atom. Okay, so it is positively charged sphere and negatively charged electrons are embedded on it. So atoms will be electrically neutral. Clear? To understand here Rutherford model of atom. Rutherford model of atom. Okay, first we discussed here Thomson's model of atom. Next one, Rutherford model of atom. Rutherford model of atom, it is better than Thomson's model of atom. Okay. Here to introduce Rutherford model of atom, scientist Rutherford did one experiment. He passed positively charged alpha particle. He passed alpha particles through a gold foil. Okay, positively charged alpha particle fall on thin gold foil. You can see here this picture. Here alpha particle hit on gold foil. Okay. He selected alpha particle for this experiment because alpha particles, positively charged alpha particles, they have higher energy. That's why he selected alpha particles. Also he selected gold foil because he want very thin metal layer. Okay, gold is most malleable metal. Okay, most malleable metal mean, malleable mean, the term malleable mean metal can change to thin sheet, metal sheet. Okay, so that's why he selected gold and alpha particle for this experiment. Clear? When he passed alpha particles through gold foil, thin gold foil, this was the observation. You can see here most of the alpha particles passed through gold foil without any deviation. Most of the alpha particles passed through gold foil without any change. Also you can see here some alpha particles deviated. Some alpha particles deviated from its path. Also very few particles, very less number of alpha particles rebounded. Okay, it reflected in 180 degree. Very few alpha particles reflected or it came back. Okay, so this was the observation. So what was the experiment? Here Rutherford passed alpha particles through thin gold foil. This is the experiment. Observation. Most of the alpha particles passed without any deviation. Some alpha particles deviated from its path. Very less number of alpha particles reflected. This was the observation. After this observation, he concluded that most of the space of atom is empty. The first observation, most of the alpha particles passed without any deviation mean most of the space of atom is empty, nothing. Okay, and also second observation, some alpha particles deviated. Positively charged alpha particle deviated means you can see in this figure in the middle of atom there is a positive center. That's why positively charged alpha particle deviated. Okay, so here first conclusion, most of the space of atom is empty. Second one, the middle of atom there is a positive center. Clear? The third observation was few alpha particle rebound. Few alpha particles, very less number of alpha particles reflected mean in the middle of atom there is a positive center. It is hard, it is very hard. Also the size of positive center is very small. Very small. You can see here in this figure, in the middle of atom there is a positive center. Compared to total atom, it is very small. That's why very less number of alpha particles reflected. Okay, so this was the conclusion. Most of the space of atom is empty. Second one, in the middle of atom there is a positive center. That's why some alpha particles deviated. Third observation, in the middle of atom positive center it is very small, very small. That's why very less number of alpha particles rebound by 180 degree. Clear? So this was the Rutherford experiment. observation and conclusion. Experiment. He passed fast moving alpha particles through a thin gold foil. It was the experiment. From this experiment, the observation was most of the alpha particles passed without any deviation. Okay, some of the alpha particles deviated. Third one, very less number of alpha particles reflected, rebound. From this, he concluded that most of the space of atom is empty. Second one, in the middle of atom there is a positive center. Third one, positive center is very small. Okay, so this was the experiment, observation and conclusion. From this experiment, observation and conclusion, Rutherford introduced his model of atom. So here we can explain Rutherford model of atom. According to Rutherford model of atom, in the middle of atom there is a positively charged center. Rutherford called this positive center is nucleus. Okay. Also, according to Rutherford model, negatively charged electrons are revolving around positively charged nucleus. This is Rutherford model of atom. According to Rutherford model of atom, positively charged in the middle of atom there is a positively charged center called nucleus. Around positively charged nucleus, negatively charged electrons are revolving. Clear? And here Rutherford model of atom also called planetary model of atom. You know, it is very similar to solar system. In the middle there is sun. Around sun different planets are revolving. That's why this model of atom also called planetary model of atom. Clear? Okay, next one we have to understand here drawbacks of Rutherford model of atom. We learned Rutherford model of atom. There are many positive points in Rutherford model of atom, but it is not 100% success. There are many drawbacks. Okay. Here we have to discuss here drawbacks, the failure of Rutherford model of atom. See this picture. We discussed Rutherford model of atom. According to Rutherford model of atom, in the middle there is a positively charged center called nucleus. Around nucleus, negatively charged electrons are revolving. This is Rutherford model of atom. Okay. See here in this picture, according to Rutherford model of atom, negatively charged electrons are revolving around positively charged center. If a charged particle like electron continuously revolving around positively charged nucleus, electron will radiate energy. Electrons will lose energy. And this electron, after losing energy, electron will come near to nucleus. It will come near to nucleus like this diagram, like this picture. You can see electron will come close to nucleus. Again it radiates energy. Again it will come close to nucleus. Finally electron will join with electron. Finally electron will fall in nucleus. Okay, it means there was one electron, finally it disappeared. It is not possible. Matter can neither be created nor be destroyed. We learned. Okay, so this Rutherford model of atom is against this law. It is not possible. It is impossible. Okay, that's why Rutherford model of atom failed. Okay, so what is the reason to fail Rutherford model of atom? According to Rutherford model of atom, negatively charged electrons are revolving around the positively charged nucleus. if negatively charged electrons are revolving around positively charged nucleus, electron will radiate energy. Electron will lose energy and electron will come close to nucleus. Okay, finally electron will fall on nucleus. It is impossible. Okay, this is the drawbacks of Rutherford model of atom. To overcome these drawbacks, scientist Niels Bohr, another scientist Bohr, he introduced another model of atom. This is called Bohr's model of atom. Bohr model of atom. You can see here, this is the picture for Bohr model of atom. Okay, according to Bohr model of atom, electrons are revolving around the nucleus in a particular orbit. Look here, this is nucleus. Around nucleus there are circular path. This circular path is called orbit. The term orbit also called shell. Okay, this orbit or shell introduced by Niels Bohr. Okay, here electrons, we can see electrons over here. Electrons are revolving around circular path. This circular path called energy level, or you can say orbit or shell. Okay, this term introduced by Niels Bohr. So here this is nucleus, first orbit, second orbit, third orbit, and so on. Also it can represent K shell, L shell, M shell, etc. Clear? So this is Bohr model of atom. Also, according to Bohr model of atom, each orbit they have fixed amount of energy. Each orbit, first orbit, second orbit, third orbit, each orbit they have fixed energy. Okay, here one electron receive energy in first orbit, they receive energy, then this electron will go to higher energy. One electron in first orbit, they receive higher energy, then it will go to higher energy level. It will go to second orbit or third orbit. Similarly, one electron in higher energy level, it lost energy, then it will come back to lower energy level. You understand? These are the different points in Bohr model of atom. So according to Bohr model of atom, here around nucleus there are circular path where electrons are revolving. This circular path is called orbit or shell. Each orbit they have fixed amount of energy. Electrons in lower energy level, it received energy, then it will go to higher energy level. Electrons in higher energy level, it lost energy, then it will come back to lower energy level. So electrons can go to higher energy level and lower energy level. It do not fall into nucleus. Okay, it will reach in first energy level if it lost energy. Clear? It will not go to the nucleus. So these are the different points in Bohr model of atom. Clear? So these are the different points we have to discuss in structure of atom. First we discussed Thomson's model of atom. According to Thomson's model of atom, atoms like a positively charged sphere and negatively charged electrons are uniformly distributed. After that, we discuss Rutherford model of atom. Rutherford model of atom. According to Rutherford model of atom, in the middle of atom there is a positively charged center. Negatively charged electrons are revolving around nucleus. This is Rutherford model of atom. After that, Bohr model of atom. According to Bohr model of atom, around nucleus there are circular path, orbit, energy level. This term introduced by Bohr, Niels Bohr. Around positively charged nucleus, there are circular path called orbit where electrons are revolving. When electrons receive energy, it will go to higher energy level. In higher energy level, electron lost energy, then it will come back to lower energy level. Electrons can go to higher energy level and lower energy level according to their energy. Okay, so these are the different points we have to discuss about structure of atom. Okay, next one we have to understand here electronic